Alrighty, so example 4. Given this, again, we go back to our original chart and see which one it looks like. We have a plus sign. So that's going to be this middle one. Our A is obviously going to be 1. Once we find our A, we can use x equal to a tangent. So we just have x is equal to tangent. We find the derivative, and then we just do the same steps, okay? So now instead of x, we are now going to write tangent theta. So it's going to be the square root of 1 plus tangent squared, and then over tangent, okay? And then our dx now becomes secant squared theta dx. Secant squared d theta, okay? Now, from here, we can use our given part. We were told that 1 plus tangent squared is equal to secant theta. So that means on the inside, I don't know why I keep writing this the wrong way. Maybe I was looking at the wrong one. Yeah, maybe I was writing the bottom one. You see that these are actually the exact same thing, right? Same thing, right? One just has the plus 1 and the other one just has the minus 1. So maybe I just wrote it wrong, but essentially, yeah, I'm sorry. So the 1 plus tangent squared theta is equal to secant squared theta. So this portion right here can now change to secant squared theta. I don't know why I wrote it like that. Okay? And then we still have this secant squared on the top. And then on the bottom we have tangent. Okay? So this secant squared and this radical cancel out, so we're left with 1 secant. We already have 2, so that leaves us with 3 on the top, and then we have a tangent theta on the bottom, okay? So from here, you can go back to your chart, for example, from section 7.2, and see what you got. So we look on here, and we have secant and tangent, so it's going to be that second chart. We have secant even. We do not have secant even. And we do have tangent odd. I probably tried both of them at some point, and I only wrote one on the paper, but essentially it didn't work. So I had to go about it a different way. When you're trying to use these charts and it doesn't work, that means that you need to try to rewrite it. So think about, remember when we had those indeterminate forms and we were trying to work it and it just wasn't coming out? Essentially that's what we're doing here. We need to figure out how to rewrite it, right? Using like a crazy one or something to get our answer. Okay, so essentially we know from up here that secant squared minus 1 is equal to tangent theta, or that secant theta is equal to tangent squared theta plus 1, right? If we move the 1 to the other side. So essentially we have 3 here, so we could split that into 2 and the 1. I originally did that, but that's actually still going to come in handy. So if we continue to split this up, I know I've marked through it, but I'd actually leave it, okay? Essentially, because we have this squared right here, we can rewrite it as tangent squared plus 1, okay? So that's what I've done on the next step. So I have secant theta, and now instead of secant squared, I have 1 plus tangent squared theta all over tangent theta. So we still have the exact same problem. We've just rewritten it in another way, which will help us to solve the problem, okay? To get rid of parentheses, first you check the power, then you distribute. So I've distributed this to both of these parts. Remember, when you're working with fractions, you can always split it up as long as your denominator is the same. So I put the tangent theta under both of them, and then I split this up. So the first one will be secant theta, and the second one will be plus secant tangent squared, okay? And then simplify. When you simplify over here, this tangent on the bottom will cancel with one of the tangents on the top. So you're just left with secant tangent. And then over here, we have secant tangent. Remember, secant is the reciprocal of cosine, so it's the same thing as 1 over cosine. Tangent is sine over cosine. Remember, whenever you have anything divided by a fraction, you do keep, change, flip. So you would keep this top part, change the multiplication, and then flip the fraction. So we'd have cosine over sine, right? Then these cosines would cancel, and you're left with 1 over cosine, and 1 over cosine's reciprocal is cosecant. So that's where the CSC came from, okay? And then from here, whenever you're working with integration and you're you have multiple parts, you can actually split them up, right? So I've done 2 integrals, and they're separated by this plus sign, so I put the plus sign there, and then I put this cosecant here and the secant tangent here. And then we go all the way back to 7.1 on page 81 to figure out how to take the derivative of this right here, okay? I'm actually going to give you guys that chart on the test, so no need to freak out, I guess. I don't think I have I didn't write down the chart, but yeah, I will give you that chart on on page 81 for the test for time crunch purposes. But yeah, so we can rewrite this integral as this red part, and then over here, to find the integral of secant tangent, remember we work backwards. So if we're looking from Cal 1 on our derivative chart, we have sine, cosine, tangent here. Then we have CSC, SCC, and cotangent here. This one's written twice, so that has to be one of these top 2, right? So here is going to be secant tangent. So remember, your derivatives are going downward and your integrals are going upward. So this box right here is the secant tangent, so right above it is secant. So that's where that's coming from. We're not evaluating it from anything, so that's why we have the plus c. Again, now we have theta, so we have to reverse everything and bring it right back to our x. So we look at what we have. We have our theta, so now we're going back to trig. We know that x from the very, 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 very beginning is equal to tangent theta, so that's what we'll start with. Tangent is opposite over adjacent. X is the same thing as x over 1. Okay, so we have x as our opposite, a as our adjacent. We use the Pythagorean theorem to find our hypotenuse, and now we need to figure out the trigs for cosecant, cotangent, and secant. Okay, so CSC is this the reciprocal of cosine, right? Or sorry, is the reciprocal of sine. So if we're looking at SOHCAHTOA, I'm actually going to go ahead and draw it in this box. This would be easier. So sine is O over H, cosine is A over H, and tangent is O over A. So essentially, you just have the reciprocal straight across. If this is O over H, this is H over O. If this is A over H, this is H over A. And if this is O over A, this is A over O. So we're working with CSC here. CSC is going to be H over O. So we take our hypotenuse divided by our opposite, which is X. We have cotangent, which is here. So that's going to be our adjacent, which is 1 over our opposite, which is X. And then secant is our secant is here, reciprocal of cosine. So that's going to be our hypotenuse divided by our adjacent, which is 1, which is essentially just the radical, right? And then we just plug those things in. So we have the natural log of the absolute value. Instead of secant theta, we are now going to write the square root of 1 plus x squared over x, minus, instead of cotangent theta, we're now going to write 1 over x, close the absolute value, plus, instead of secant, we're going to write our radical plus c. And that would be the final answer.